Hello, I am Bernhard Mickel from Hemper Photonic, and this video is about design optimization in RayJack ONE. What is optimization? The goal of optimization is to find the minimum of a function f of x, or at least a sufficiently good value below a certain target t. F is called the merit function, and x is the design variable. In practice, one typically has not just one, but several or even lots of design variables. And we use an iterative process to find the minimum. The success depends on the start value. Let's start here. When I go down, simply downhill, it's obvious that at some time I will even reach the global minimum. Whereas when I use this value, it can be that the algorithm gets trapped in a local minimum, so that I have to start again with a new start value. In non-imaging optics, the merit function is often non-continuous or even noisy, so that you need very robust algorithms for optimization. In RayJack ONE, optimization is implemented as a Python script, and you can use built-in optimizer solutions or reach out to the internet to find your favorite optimizer. Let's start with a very simple example, which I run here. It's a lens where the second surface is curved, and the goal is to create a best possible focus here. Let's have a look into the script. So the lens surface is defined by its radius of curvature, its conic constant, and aspheric terms. And also I can set the number of rays, and if show is true, it will be displayed, otherwise not. Finally, here is the system setup. Here the ray tracing, and RMS gets the RMS spot size on the image plane, which is used as the merit function. Now, in optimization, you need to change parameters from outside the script. And the typical Python trick to do it is as follows. You simply indent here and then insert a line like this. This means when you run the script directly, then these parameters are read in. Otherwise, if you load it from another script, this part will be ignored. Now let's turn to the optimizer. It's called here like optimizer. Then you specify the name of the simulation file and a log file to track the optimization progress. Here you specify the merit function, which was RMS, and here you set the design variables. So the radius of curvature, conic constant, and aspheric terms with their current values, their lower and upper bounds, and initial step sizes. Actually, I do not even want to vary the aspheric terms, therefore I specify here that I would like to keep them fixed. So in the first round, I run the system again and show it to see how it looks like. Then here, this is the optimization run. And finally, I show the system after optimization. Let's do it. So this is a really bad start design, but it does not take too long, and we have the perfect solution. And in practice, you often need many analysis tools to understand what's going on during optimization. Here's only a simple example where I plot the merit function. And you see, in a logarithmic scale, after a while, it's going down here to 10 to the minus 6. And if you continue, it would go down to 10 to the minus 13 even, because in this case, we really have an exact solution. And thank you for your attention.